Welcome to this tutorial on Visual Studio Toolbar for VSmex interface. The way you probably found this tutorial is through the Matlab file exchange page, and I should mention right away that the code found there is not the most updated version. Since that submission, I have made a proper plugin for Visual Studio both 2010 and 2012. And the way to find that is to follow this link, which will provide you with a nice little zip file in which you will have the Visual Studio 2012 and 10 versions. Now, these are special files with the file ending VSmex, which is the common way to have Visual Studio extensions. In order to install this, you will probably automatically be instructed to download and install the library required for these sort of extensions, and that's pretty standard and nothing to worry about. And after that, it's a simple click install instructions, very easy to do. Apart from the zip file here, you should also download the submission, because in it you will find two convenient source codes that we will use as our first examples of C file mixing. These two. Once your installation is done, Visual Studio's interface will be modified in a small minor ways. The first thing that's obviously visual is the new menu option called Matlab. You'll have 4 options there, and we'll go into detail what those are sooner in the tutorial. Also, I recommend that you add the toolbar version of this over here, which you can simply do by right-clicking here and enabling it from the options. A third difference, very small one, is that you'll also have a new options page called Matlab Tools. In it, there's only one possible option that you can set, and it is the path to the Matlab executable. You don't need to set this, especially not if your Matlab executable is in the root. But on some systems you might have several Matlab versions installed, so this allows you to specify which executable is run. After installation, let's go right ahead and try out the 2 example files that was provided with the file exchange submission. I've extracted them to a folder, and now we simply pick one and open them. We'll first look at the silly VSmex.cpp file, as it is the easiest one. Here we have it, open in Visual Studio, and it looks pretty straightforward. It's a very simple file, and all it will do is say "Hi world" and then "Hi world" again. VSmex works on the principle of having a Matlab file being executed every time you want to run the code. So there has to be an associated Matlab file for every main mex function. That associated Matlab file should lie in the same folder as you have your source files. Right now, our source files are in this folder. The one we're looking at is called silly VSmex, and we do not have such a Matlab file. The first option of the VSmex toolbar is View, and it shows us this Matlab file. VSmex then correctly identifies that no such Matlab file exists and asks if we want to create a generic one, which we do. After that, it gets opened up in our preferred text editor, so we can look at the contents. The contents of this Matlab file right now is not very complicated. Go to the top, we see that it's a function. It receives one single Boolean variable, which indicates whether we want to run this in debug mode or not. And then it correctly sets up the call to mex inside of Matlab. This is the line that will build the executable mex file in Matlab with the debug switch. And this is the regular one if we want to build for a release version. After that, the Matlab file calls the newly created function, and this is an important line because later on we may want to put in specific data to send in and retrieve specific data, followed by some Matlab commands to visualize the results to make sure that we've actually computed the right things. Now, we go right back to Visual Studio, and once we are sure that we have a working Matlab file, we simply click Run. Now what's going to happen is that VSmex opens up a thin client of Matlab. So it's not the regular version that you usually get when you just click the Matlab icon or you run it from the command prompt. And this is a very fast, thin client to start up. And as you see, we got the results very quickly. And Matlab also, it outputs the expected results of Haya World, and we were notified that there are no errors. We hit a key and we exit Matlab. Sometimes we want to run Matlab in an even thinner client than with the run option. A thinner client is achieved by not having any Java support in it, and that option is available as run fast, which for some reason in this case does not bring the command window into focus. But anyway, it's very fast, as you can see, and this also includes compiling the file. In the run fast mode, you will have a much smaller memory print of Matlab, but because you don't have the Java machine, you lose many of the functionalities of Matlab. So it's suitable for when you do intensive computational stuff, but you don't really require any visualizations or don't require the underlying functions of the Matlab virtual machine. And finally, the fourth option in VSmex, the debug one, is for debugging the code, which will be handled completely inside of the Visual Studio debugger. In order to visualize this, we would need some kind of breakpoint, and we can simply add one here. After which, instead of using run or run fast, we'll click debug. Now, this automatically puts Visual Studio in debug mode, and when we build the VSmex file with the Windows with the Matlab script, and automatically when it's run, we'll switch back from the Matlab thin client into Visual Studio debug mode. And if you're used to the Visual Studio debug mode, you'll recognize right away this sort of interface, a very nice debugger indeed in Visual Studio. And we can see that right now the counter is here, and we can step forward if we like, or we can even continue execution because there's not that much interesting happening. And as we expect, the program ends without fault, and we can go back and exit the debug mode. Let's take a look in the folder where we have our two CPP files. We can see that several new files have been added. The most important one for our purposes is the one called debug silly first mex cpp.m, and that is the Matlab file we viewed previously. And also we have the mex executable, and we have also the the debug file needed for our Visual Studio debugger. Next, we'll open up our second file, which contains a little bit more interesting code. It's mygetpr.cpp. As before, we'll click View, and VSmex will generate automatically a generic Matlab file as such. But if we take a look inside of this file, we can see that it actually handles some input. That means that we cannot run this file without any input arguments. First though, let's take a look at what this file actually does. It is, as the previous one, very simple, but actually a bit useful because it does output the address of the input variable, something that you can't often do with Matlab. So let's see if we get this correctly. It requires one input from Matlab, and that should be just any variable whose physical address we're interested in. And it also requires one output. It does not require one output. If one output is not provided, it will echo something back to the Matlab prompt. And the rest of the file, well, it's not that complicated, but it's not really the focus of this tutorial right now. It simply gathers the address and then outputs it. So if we try to run this as is with the generic file, we're not going to send anything to the function. So we expect some kind of error to happen. In this particular case, we have that error handled in the code. So we output this error message, require 1 arg, a message which we recognize from the code over here. So the way to solve this is to go into our generic file, go to where we make the call to the function, and instead of just calling the function without arguments, we make some variable a, give it some value, 100 perhaps, and send that variable in. This particular syntax would then, hopefully, echo something back to the Matlab prompt. Save that file, go back to Visual Studio, and we try running this again. As we expect, we get some useful information. To make it, well, not more complicated, but more useful, we can go back in here again and try out the other syntax, where we save the output B, and then we choose to display the value of B. Save the file, go back to Visual Studio, and we run it again. This time we simply output the value. To finish off this tutorial, I'd like to show you a use case of when the VSmex toolbar is very useful. So in order to do this, let's go to the Matlab interface and try to do some Mex development. So here we have, this is my Matlab instance. I am right now in the folder. I am right now in the folder where I have my CPP files. In here I can look at the same CPP file, and we can see that the syntax highlighting works for C code, which is one benefit of Matlab. But what happens if we have some error? This code works now, we've seen that, and it's a very simple piece of C code. But even with simple C code, it's very easy to make errors. One such error is indexation, perhaps the most common one. The most common one that yields runtime errors and not compile time errors. Right here we have a line 34 in the code, which outputs a value back to the Matlab workspace. What if we, instead of indexing this as 0, which is correct, go out of bounds by 1? Let's save this file and let's do this mexing, this compilation in Matlab in the traditional way. To mex a file we call mex specifically, and that's going to work. As we did in our Matlab initialization file, let's make a variable a to be 1, and then we'll call our newly made function in such a way. Now, for those of you who have developed in Mex before, this is a very common case. Matlab crashes. There's no information in the details here. There's no valuable piece of information at all to what is wrong in the program or where it is. And the only thing you can really do now is click End Now, which will kill Matlab. So, this is quite annoying for many reasons. For one reason, it takes quite a bit of time to open up Matlab again, especially if you want to try out many small corrections in your code. Let's see how we would handle this using VSmex instead. First of all, we're working in Visual Studio. So here we have the same code with the same error, and if I now run this, well, we'll get exactly the same kind of error. So that doesn't help us anything at all. But it doesn't take so long to start this up, especially if we do it with the run first version. It compiles and runs very quickly. Secondly, because we now know that there's an error somewhere, we might want to actually start debugging this. In order to debug this code, we simply put a breakpoint somewhere in the code. It's not a very big code, so we can put it pretty much anywhere, preferably before the bug. And after that, we'll run it with the debug. and see what happens. It still compiles and runs reasonably fast. And as we see, as we expect, the Visual Studio debugger executes the, breaks the Matlab regular execution to bring it into the Visual Studio debug mode. And here we are. At this point, nothing has gone wrong, no crashes has occurred, no out of bounds error. As with any good debugger, and Visual Studio Debugger most certainly is good, we can step forwarding code and execution, which we do now. And we can, as we do this, investigate all the variables of interest, which we have down here. We have the call stack, which doesn't change that much in this single function, but we can keep going as if we don't know where the error is. And finally, at some point, this being the line of the error, something will go terribly wrong. We get the little bit more informative error now. Well, essentially that something is wrong on the Matlab side. And as such, we know the line where the error is. We also have the full call stack of when the error occurs, and we have the values of all the variables and pointers and such. So this is very valuable, and at this point, as a developer, we would just simply investigate this line and probably find this simple error that we have and change it back to the correct value. And after that is done, we'd like to stop debugging, and the unavoidable error of Matlab will still occur. But naturally speaking, when we've done with this, we can save the file with a new modification and we can run it again. And as we know, then things will work out as we expect them. So that concludes this tutorial, and I hope you find the VSmex a useful tool. I've used it myself to great effect in both education and in professional work. And if you find it to be lacking in any way, I hope you get in touch with me. So thank you for your attention.